Bonjour, bienvenue au Bracket Show. Ici avec Eric de Carufel. J'ai avec moi David Ostrovsky.
Yeah.
Okay. David, can you tell me about yourself, what you're doing in life, and what's your main functions?
So I'm an architect at Proofpoint, which is a large software security company. I lead architecture for all of our cloud security products. I build large distributed systems for a living, and I play a lot of video games not for a living.
Okay. And what do you want to talk to us about today?
So I just did my talk on observability in distributed systems, which is a topic I'm very passionate about. I talk about this a lot. The gist of it is what is observability, and how you actually build it into a large software system, and why you would even do that, right?
Yeah. The main question is why do we have to do that first? Yeah.
So think about this right now. How many people who work on production systems can confidently say at any given time that their system is working exactly as expected? That's a very bold statement to be able to say, I know right now, without a doubt, that my system is working okay, right? And really that's the gist of observability, being able to answer questions like, is my system okay right now? And if it's not, what's wrong with it?
It's more than just reading logs, I suppose.
Yeah, so when you go to conferences and blogs about observability, you'll find this holy trinity of logs, metrics, and traces, which supposedly comprise observability, but it's not really the case. It's not a product you buy. You can go into a vendor and say, I'll buy 3 observabilities, please. Right? That's not the way it works. They're just technologies which you use to achieve a business goal, right? Because observability is ultimately a business goal. It's as much a feature of your system as a nice UI is a feature of your system. You want to be able to know about the internal workings of your system and be notified automatically if something isn't correct, right? And yes, you achieve that through a combination of collecting metrics and collecting logs and collecting distributed traces through your system, and then building a smart enough system around it to actually create proactive alerts that will warn you about impending problems and let you quickly zoom in on which exact area of your system is malfunctioning. And if you have all of those things, if you can confidently say, I know that this is wrong and this is where I need to be looking for an answer, then you have good observability in your system. And it's a moving target. You can always find new problems and find new things you can improve observability in that specific area, right?
So the way to achieve that is that to introduce new things in your code to make that observable, or is it an external system that do the job?
So it's a combination of both. You want to instrument your code, ideally with as little effort as possible, to actually emit enough information outside of the code to a third-party system which can do all the rest, right? You can collect all the information, make it nice and presentable, create alerts on top of it, connect to common external systems like PagerDuty to notify you about problems, and it's the total of it, right? But like you said in the example with the logs, right? Logs are a combination of some instrumentation you do in your code, and then some external system which takes the logs and puts them in a centralized, searchable place. And it's the same thing for any one of the other components. Same thing with metrics, right? You instrument your system, emit all your metrics or all your traces, collect them together, and the trend in the industry right now is to actually combine all of these things in one place, right? If you go and you look at the big vendors like Elastic, the whole selling motion of Elastic is, oh, we have this magical APM system which takes in logs and metrics and traces together and shows all of them, right?
But how do you trace which problem is related to which action? How do you trace the action all the way from the first request to the application to the actual problem?
So there are a lot of techniques, but they all really boil down to, at the boundaries of your system, you have to generate some kind of unique ID to this particular transaction or action, and then propagate it through the rest of your system. And there are various tricks around it and various tools like OpenTelemetry, which is a vendor-agnostic library that's very popular right now, that helps you instrument your code in order to propagate this trace context from service to service. And it depends on your transport, right? If you're using HTTP, it has headers. If you use some messaging queues, they have other systems. But ultimately, the gist is, instrument your code to actually generate this trace ID at the boundaries, persisted through service transactions, and then emitted in every service, whether it's into logs or into a separate tracing system, collect it all centrally, and then you'll be able to correlate a bunch of different disparate log messages into one cohesive transaction and say, oh, this is where it happens and this is where the problem is.
So I suppose this ID must be generated by the first request, or by the client itself, or by the mobile app, or by anything that is
Yeah, obviously it depends on the system, but basically at the boundary of your system, in this case might be between the mobile app and the service. If it's a web system, between the client and the server. If it's, for example, the kind of systems I normally work at Proofpoint, they're mostly backend systems, so at the first first service which generates some piece of data, it assigns the ID, and then that transaction might take a million different paths through the systems, split into a bunch of different subservices, converge or be stored in a database. But as long as you generate it upstream enough, you will be able to trace everything downstream from it, obviously, right? And if for example, you do it on the server, then yes, you're missing the coverage for the client. So maybe you can generate on the client. There are some issues with that as well. It's really up to you, but again, whatever you generated, then you trace everything downstream from that.
Yeah, okay. And if I have a system that don't have any traceability for now, where do I start?
Specifically for tracing, right? The best place to start is go to the OpenTelemetry website and just read their code samples and look at some of the demos they have, because it's fairly straightforward and they have libraries for most of the common languages and frameworks these days. And you start there, and generally, if you want to put this into production, I believe it's best to start in the most critical part, because I know mostly engineers have a tendency of introducing new things at the edges where it's not critical, it's not going to hurt anybody. But when it comes to observability, that also gives you no value, right? If you have very observable edges of your system which are not mission critical, there's no value out of all the effort you put in there, right? You find the most critical thing, the thing where if you have better observability, you'll actually feel the impact, instrument that, trace that, and then if you prove your value on that part of the system, then you can take it further, right?
So would you suggest to go inside out from the system? So you go from the most insided part of the system, and then you grow your observability out of just at the edge at the end.
Yeah. Find the most mission critical part. If you have a web server with 50 endpoints, find the one that gets called the most and gives you the most trouble. Instrument that one and everything downstream from that, and then you'll feel some ROI. Because if you don't, fine, delete all of this. I don't believe that will be the case, but nothing happens. But if you feel there's ROI in actually improving that part of the system, then you can actually show a business case. Because again, a lot of the time, improving observability does not get the same respect as like improving the UX, because it's not visible, it's not in your face. You go to whoever is in charge of the business of your system, product managers, business owners, wherever, and you say, well, we need to spend a month now adding traces. And if you just say that, obviously there's no value to that statement, there's no business case, right? You have to go and you have to show ROI to the system. For example, if you have some rudimentary tracing, you can go and look at the metrics for the past month and say, did you know that our system has been down, 7% of the time? Which is like, oh my God, 7%, we're under our SLA. Then you have the business case to go and improve things, and the more observability you add, the better business case you build for adding more, because you have more understanding of your system.
So observability is one part. Do you have a plan to react to that visibility or observability to take some decision based on what you observe?
So I don't see that as separate parts. When I say observability, I mean the whole shebang, right? It means alerts, adding alerts, and iterating over which thresholds you alert on, connecting it to some kind of system which has an escalation chain, and calls someone in the middle of the night and wakes them up. All of those things are all part of the whole observability thing, right? Yeah. Including, let's say, end-to-end tests, if you run occasionally. In our system, it's a very complex system. There's a lot of code paths through it. It's very hard to cover everything with unit tests, so we actually have end-to-end testing running continuously on the production system to make sure that we test every possible or common code path, right? All of that stuff, that gets fed into the same observability total, right, whole.
That's nice. So thank you very much.
Yeah, my pleasure.
Thank you.